Hi, AS Physics Warriors. Welcome back to Tanya Chew Physics Mastery. If you're studying for your AS Physics exam, you must watch this. In this video, we are diving straight into AS Physics Major 2025, Paper 1, Variant 3, MCQ questions. I'll go through each question step by step. So you will not only get the right answers, but you will understand why they are right. So grab your calculator. Let's tackle this paper together. Let us begin with the first question itself. Question number one. What represents a vector quantity? Now, a vector quantity is a quantity which consists not only magnitude but also directions. Let us look at the first one. 1 Newton upwards. Newton is the unit of force and it is going upwards. Force is a vector quantity. Direction is outwards. So this is the answer. B. 2 kilogram decrease. Kilogram is the unit of mass. A decrease in mass, it is not a vector quantity because mass itself is a scalar quantity. Now C, 3 Kelvin cooler. Kelvin is the unit of temperature. So temperature is also a scalar quantity. D, 4 seconds later. Second is the unit of time. Time is also a scalar quantity. That is why the answer is A. Number two, what is the reasonable estimate of the current in an electric kettle? So bear in mind, electric kettle is used to heat out the water. So that is why the current used cannot be too small, cannot be in microampere, cannot be in milliampere, and cannot be too large. 8 kilo ampere, this is 8,000 ampere. That is way too large. So the best answer is C. The reasonable estimation of the current is C. Number three, which statement about errors in measurements is correct? Let us look at A. An accurate set of measurements always has a small random error. No, it is not small random error because random error is an error coming from everywhere. You don't know what is the main cause of the random error. So an accurate reading, right, has small systematic error. B, a precise set of measurements always has a small systematic error. A precise readings are the readings that are close to each other, but not necessarily close to the true reading. So that is why they always has a small random error because all the readings are scattered around, right? But they're close to each other. So this is wrong. C, a random error can be reduced by taking an average of several measurements. This is absolutely true. Why? Because random errors, like what I told you, we don't really know the main cause of the random error. So it could be from anywhere. So if you want to reduce it, the only way that you can do it, you cannot eliminate random error because you don't really know what is the cause of the random error. So the best way to reduce it to conduct multiple experiments and take average readings after that. D, a systematic error creates a random set of measurements spread out about a true value. So is this not a systematic error? Systematic error will only cause the reading to be shifted, right, higher than a true reading or shifted to be lower than a true reading. So this is the definition of not a systematic error, but random error. This is random error. So it is the random error that creates a random set of measurements. So the answer is C for the third question. Number four, a sample of a material has cross-sectional area A and length L. The temperatures of the two sides of the sample are T1 and T2. Thermal energy Q is transferred through the sample in time t. These quantities are related by the equation given where k is a constant. What are the SI base units of k? So if you want to find the SI base units of k, you have to do your homogeneous equation. So you have to compare the left-hand side base units equals to the right-hand side base unit. So I'm going to do it one by one. So Q represents the thermal energy. Thermal energy, it is a kind of energy. So all the energies share the same unit, which is joules. I am going to choose the energy that I am most familiar with, which is gravitational potential energy. So I'm going to do that. I am going to denote joules in terms of SI units. So mass kilogram, G, ms -2, it is gravitational acceleration. H is height, which is m. So I got the base unit of energies. All the energies share the same base unit. So kilogram meter square per second square. So I'm going to do it down here because it has more space here. Q kilogram meter square second per second square divided by, oh, what is T? T is the time taken. Time is measured in second. So it's equal to the small little k here, right here. I put a bracket. And A is the cross-sectional area. Cross-sectional area is m squared. The base unit is meter square. And multiplies by T1 minus T2. T1 and T2 are temperatures. The SI base units of the temperature is Kelvin. Just put capital K right here. And L is the length. Length is measured in meter. Now you try to simplify m squared. And then this is kilogram meter square, and I shift out the second -1, so this will be second -3. S shifted out become as -1. -2 plus -1, it is -3. So it's equal to K m times Kelvin. So you make the small little k as a subject because you're supposed to find the unit of small little k here. Kilogram meter square as -3 divided by meter Kelvin. So I have kilogram m square and m. So this will become m as -3 and k to the power of -1. So the answer is B. Number 5, the graph shows the variation of a velocity with time t of an object moving in a straight line. At t equals to 0, the displacement of the object is 0. What is the displacement of the object at t equal to 20 seconds? Where is the 20 seconds? Oh, it is right here. Now, this is a graph of velocity against time, right? How do we find the displacement? Right, to find the displacement, you need to understand when the graph is being given, there are two information that you could obtain. One is the area under the graph, the other one is the gradient of the graph. The gradient of the velocity time graph represents acceleration. So to find the displacement, it is area under graph represents displacement. So I'm going to split this displacement into two parts. One is the displacement of this part, and the other displacement is on the other side of the other small little triangle right here. So I'm going to put this area 1 and this is area 2. So I'm going to find area 1 first. Area 1. This is the area of triangle. So it is half times base 16 and times the height, which is 3. Get an answer for this. I got 24 meter. Area 2 is equal to half. It is also a triangle. 20 minus 16, that's 4. And I also want you to bear in mind that displacement is a vector quantity. So if you see a negative number, you shouldn't ignore the negative sign. I will put this as -1.5. So -1.5 is here. I got area 2, which is -3 meter. So the displacement of the object at t equal to 20 seconds is 24 meter plus -3 meter. So your answer should be 21 meter. B is the answer. Number 6, a science museum designs an experiment to show the fall of a feather in a vertical glass vacuum tube. Oh, the vacuum is the key word. The time taken, the time of fall from rest, u equal to 0, in the vacuum is to be close to 0.5 seconds. Which length of tube is required? Now, I would choose as one of the kinematics equation equals to ut plus half because it is falling. So I'm going to replace the a with gt squared. And the whole okay, ut here is equal to 0. Why? Because u is equal to 0. When you times the time, you still get it 0. So the height, okay, the length is the displacement. I put here as L. half. G is 9.81. Why? Because when an object, all the objects, when the objects are falling in a vacuum, the only force that acts on the object is the weight of the object, gravitational force, which gives rise to gravitational acceleration on the object. And T is 0.5. You just square it. And I got 1.23 meter as my answer, and I rounded off to A, 1.2 meter. Number 7, two coins are projected from a horizontal table at the same initial speed u. Coin X is projected horizontally. Coin Y is projected upwards with an angle of 30 degrees to the horizontal. Both coins hit at the horizontal ground without bouncing. Assume that the air resistance can be ignored. Let's say this is a ground. Let's say this is a ground. So coin X would travel horizontal velocity and hits the ground like that. This is projectile, and coin Y will go to a further height first. Okay, going up and then coming down. Right. So that's Y, that's X, that's the paths of Y and X. Which statement about the motion of the coins is correct? I will start with D first. Coin Y has a smaller vertical acceleration because air resistance can be ignored. Coin Y and coin X have the same gravitational or vertical acceleration of 9.81. So same vertical acceleration as coin X. So this is wrong. See, coin Y hits the ground before coin X. So could you see that coin Y will be projected outwards before coming downwards? So logically thinking, right, coin X will hit the ground first. So this is wrong. So coin X hits the ground first. B, both coins travel the same vertical distance. It is not the same because this is a vertical distance of X, and Y, it travel with the higher vertical distance. So that this is the distance of X, this is the distance, vertical distance of X and Y. So different vertical distances. A, both coins hit the ground with the same speed. Now, if you consider in terms of the energy, I'm going to use the principle of conservation of energy. So the principle of conservation of energy states that energy cannot be created nor destroyed, but can change from one form to the other form. Coin X initially has both kinetic energy plus gravitational potential energy. Before it hits the ground, coin X converted all its gravitational potential energy to kinetic energy, solely kinetic energy. Coin Y on the same hand, has the same kinetic energy plus gravitational potential energy. But before reaching the ground, a few moments before reaching the ground, it will convert all its gravitational potential energy to its kinetic energy. And both coins are given the same initial speed. So that is why they have the same kinetic energy. Right, so that is why all energy given will be converted back to the final kinetic energy, which is, yes, this is true. Number 8, two spheres are released from rest at equal heights above the ground. Both spheres reach the terminal velocity. Terminal velocity is the maximum constant velocity when the weight of the sphere is balanced by air resistance, or you can say drag forces. One sphere has a larger density than the other sphere. Both spheres have the same equal volume. So density is equal to mass over volume. Since both spheres have the same volume, one is of higher density, one is of higher mass, because density is directly proportional to mass when the volume is constant. Right? Which statement is correct? While both spheres at terminal velocity. So let us look at D right here first. The weights of the spheres are equal. Since the masses of the spheres are different due to their different densities, weight is equal to mass times gravitational acceleration. Mass larger, weight will be larger. So this is wrong. Both weights of the spheres are different. So this is wrong. D is wrong. The velocities of the spheres are the same. I would say it is wrong as well because terminal velocity, it depends on when the weight is balanced by the air resistance. So the higher the weight, so it will take more time to balance for the air resistance to balance its weight. So the velocity will be higher for the higher mass. B, the resultant forces on the spheres are equal, which is 0. The resultant forces on both spheres would be equal to 0, which is true. A, the drag forces on the spheres are equal. They are not equal. So it is depending on the weights of the spheres. Since their weights are different, so the drag forces acting on the spheres will be different. B is the answer. Number 9, which statement defines force? If you want to define force, force is being defined by Newton's second law. Newton's second law states that force is equal to the rate of change of momentum. Resultant force is equal to the rate of change of momentum. Let us look at A. When a force acts on a body that is free to move, the force is the product of mass and of the body and its acceleration. This is not true. B, when a force acts on a body that is free to move, the force is the rate of change of momentum. Yes, that is definitely true. C, when a force acts on a body that is free to move, the force is the work. There's nothing to do with the work divided by distance. That is not how we define force. So when a force acts on a lever and causes a moment, the force is the moment divided. That is not the definition of force. Force is being defined as rate of change of momentum. Just remember that. Number 10, four forces all in the same plane act on an object. What could describe the motion of the object? Okay, let us see. The upward force is balanced by the downward force. Upward force is equal to downward force. Forward force, forward force, which is 20 Newton to the right, is balanced by the backward force, or you can say force to right is balanced by force towards left, right? So I would say that, okay, the resultant force is equal to 0. So when the resultant force is equal to 0, the object cannot be accelerating. There are two conditions, okay? Two movement of the object. Object either can be at rest when the resultant force is equal to 0, or object is moving with constant velocity or constant speed. B sounds to be correct to me. C, it is moving with decreasing speed. No, speed must be constant, cannot be decreasing. It is moving with increasing momentum. That means the velocity is increasing. No, that's wrong. So B is the answer. Number 11, a nucleus collides with a stationary nucleus in a vacuum. Diagram shows the path of the nuclei before and after the collision. No other particles are involved in the collision, which diagram is not possible. So, principle of conservation of momentum must be obeyed here. Momentum before must be equal to momentum after. Remember that. Momentum before is moving in a straight line horizontally. Momentum after, okay, it has to be in a horizontal direction, no vertical direction. So I would see for the first one going upwards, so vertical, I'm resolving upwards, and the other vertical is going downward. This is possible because up and down balance each other, so there is no upwards direction. B, okay, horizontal direction. I want my vertical direction to be equal to 0. So let us see. So I will just draw this okay, horizontal line first. Okay, this is a vertical direction, and this is upwards direction. It's balanced by downward direction. Don't bother about the length of my arrows because the mass, okay, one mass could be larger than the other mass. Remember, right? I just want to find the balance. I just want to use the easiest way to see first. If it doesn't work with the easiest way, so I have to involve some a little bit complicated calculation into to find the correct answer. So upwards is balanced by downward. It seems like yes, that is possible. What about C? Okay, this is my horizontal reference line here. So C, I resolve this into the downwards direction, and I resolve the other one also into the downwards direction. It seems like there is no upwards direction to oppose because the final momentum must be in horizontal direction as well. There's no vertical direction. So C seems to be not possible, but I look at D. D, okay, this is my equilibrium position or horizontal position. Okay, this one can be resolved into vertical direction, and this one can be resolved into downwards direction. Up and down balance each other. So this is possible. This is possible. The only one that is not possible is C, because there's no upwards momentum, right, to balance it. Now, number 12, a non-uniform. Non-uniform meaning to say that the weight is not acting at the center of gravity. Bar has a length of 50 cm and weight 200 Newton. A block of weight 400 Newton is attached to the top of the bar at its center. So here, this is 400 Newton, and the distance between P to the 400 Newton must be 25 cm because at its center. And from the other end, I will draw using the blue color. It is also 25 cm, and the bar rests on the horizontal ground. A vertical force of 360 is now exerted upwards on the bar at NQ, and it is just sufficient to leave the end of Q from the ground. What is the distance from the center of gravity of the bar to NP? What is the distance? Okay, now I will have to a center of gravity is a point where the weight of the bar PQ is acting. Could you see that they give you the value of the weight, but they don't give you where the weight is acting, right? So where is the center of the gravity of the bar? So I have to try to resolve it using these two forces first, 400 Newton and 360 Newton. I will set P as my pivot. So this is my pivot. So I want you to look at what I'm about to do. Focus on 400 Newton first. 400 Newton is going downwards and the pivot is on its left hand side. So it will turn towards its left hand side, towards the pivot. This is being called clockwise direction. 360 Newton is acting upwards, so it will turn towards the pivot while going upwards. So this is the direction of turning. This is anti-clockwise. 360 Newton provides anti-clockwise moment. Right, so I am going to find my anti-clockwise moment first, right here. Anti-clockwise moment, which is equal to the force 360 multiplies by perpendicular distance from the pivot. So it is the whole length of the bar, which is 50 cm. But hey, before you sub in 50 cm, look at all the choices, the units of all the choices. It is in meter. They're in meter. So that is why I'm going to divide 50 cm. I'm going to convert 50 cm to meter. So you divide 100, you get 0.5. And here I got 180 Newton meter. What about the clockwise moment? Clockwise moment is equal to my force, which is 400, multiplies by perpendicular distance from the pivot, which is 0.25 Newton meter. So I got 100 Newton meter. And since this is just sufficient to leave the end of the Q from the ground, so principle of moment is applicable. I am going to use my clockwise moment is balanced by anti-clockwise moment. Clockwise moment is 100, so I need another value to balance my anti-clockwise moment. So I put a weight times the perpendicular distance from the pivot is equal to anti-clockwise moment. So D is perpendicular distance from the pivot, 180 minus 100 divided by 200. D is equal to 0.4 meter. So the answer is D. Number 13, what is the definition of density? Density is being defined as mass per unit volume. Mass per unit volume, the answer is D. Number 14, a block is in equilibrium on a slope. Which vector triangle represents the three forces acting on the block? When this is about forces in equilibrium, just bear this in mind. You will be able to plot a closed vector triangle which the directions of the forces follow each other. Right, so look at A. A force is going down and being opposed by this outward force. So this is not in equilibrium. B, force going down, and the second force is also downwards, but it is opposing by the third force. This is not in equilibrium. C, the force is going upwards. Doesn't matter. The arrow is going downwards and then followed by upwards. So this seems to be correct. That is one way to draw the cross triangle. D, the force is going up and it is opposing by this force. So this is not in equilibrium. So C is the answer. That is the easiest way to do. Now, number 15, a measuring cylinder contains 80 cm cube of a liquid. The pressure due to the liquid at 60 cm cube mark is 1,200 Pascal. What is the pressure due to the liquid at the base of the measuring cylinder? So I will draw the measuring cylinder right here. So this is the measuring cylinder. Okay, this is 60 cm mark, 60 cm cube marks, and this is 80 maybe. Okay, 80 here. And then they say that the pressure here is equal to 1,200 Pascal. And they ask you to find the total pressure at the base. So I am going to use this method to do. I'm going to use the P1 Boyle's law. P1 V1 is equal to P2 V2. Now P1, pressure 1, 1,200. Volume is 60. Pressure 2, I want to find the pressure 2 when the volume. The difference between these two liquids, right? It is 20 cm cube. So I'm going to find, okay, volume at 20 cm cube. Then I will add out all the pressure. Right, so pressure 2 would be 1,200 times 60 divided by 20. Pressure 2 is equal to 3,600 Pascal. Now, what am I going to do is that I am going to find the total pressure. Total is equal to 3,600 plus 1,200. So I get 4,800 Pascal. D is the answer. Number 16. 4 identical uniform blocks are separated on a table. Each block has a mass m and thickness h. The acceleration of free fall is g. How much work is done on the block in stacking them on top of one another? The work done is in terms of gravitational, the gain in gravitational potential energy of these blocks. So when you stack only one block, the initial height of the block is already h. So when you stack one block up of it, right? So stacking one block, stack one block. The gain in gravitational potential energy is mgh. The difference in height will be 2h minus h, which is h. When you stack two blocks, so the difference, okay, two blocks, can you see? When you stack two blocks out of this one block, so 3h minus h, so you have mg 2h. When you stack the third one, blocks, there are 4 blocks only, you can only stack 3 blocks on top of the first one. So this is 4h, right? So 4h minus with the h, so you get mg 3h. So the total total work is in terms of total gravitational potential energy, mgh plus 2 mgh plus 3 mgh, and you gain 2 plus 3, 5, 6 mgh. So the answer is B. Number 17, an electric motor uses 1.7 kilowatt of power when operating normally. The efficiency of the motor is 53%. What is the useful output power of the motor? So I'll just write down efficiency is equal to the output power divided by input power, and you have to times 100%. Efficiency is given as 53%. You have to find the useful output power. Input power is 1.7. Not going to change the kilowatt because I look at all the 4 choices are measured in kilowatts. So times 100. So the output power is equal to 53% divided by 100% times 1.7, and I got 0.901 kilowatt, and I round it off to 0.90 kilowatt. B is the answer. Number 18, a ball is released from rest. This is U equal to 0 and falls vertically to the ground. The kinetic energy, EK, of the ball varies as the height of the ball above the ground changes. Air resistance is negligible. This is good news. No other resistive forces acting on the ball. Which graph shows the variation of EK with H? Now, when the ball is released from a certain height, the ball initially has gravitational potential energy, which after that converted to EK. So the energy changes from gravitational potential energy to EK. Right? Gravitational potential energy is mgh, right? Converted to EK, kinetic energy. So when the height is at maximum, EK is minimum. So EK is inversely proportional to height. So because the GPE is converted to EK, so when the height is maximum, the EK is 0. And this is linearly related because air resistance is negligible, so there is no curved graph. So D is the answer. Number 19. An object traveling with a speed of 10 meters per second has kinetic energy of 1,500 joules. The speed of the object is increased to 40 meters per second. What is the new kinetic energy of the object? First of all, I am going to use the equation of the kinetic energy to find the mass of the object because I do not have the mass of the object. So half mv squared, that is the equation or the formula of the kinetic energy. So kinetic energy is given 1,500, which is equal to half. Mass, I don't know. And V is 10, you square it. Mass is equal to 1,500 times 2 divided by 1. 10 square is 100. So you get 30 kilogram right here. Once you get your 30 kilogram, it's very easy to find the new kinetic energy, which is half mv squared as well, using the same equation, but the mass would not change because it is the same object. And 40, you just square it, and I got 24,000 joules. C is the answer. Number 20, what are the units of stress, strain, and Young modulus? Let us look at stress first. This is a symbol of stress. It is being defined as force per unit area. The unit of stress is Pascal or Newton per meter squared. Strain, this is a symbol of strain. It is being defined as extension over original length. Extension is measured in meter. Original length is measured in meter as well. So no unit for strain. Young modulus depends on stress divided by strain. Since strain has no unit, Young modulus would take the unit of stress. So the answer is D. Number 21, the force extension graph for the metal wire is shown. Which quantity is represented by the area under the graph? The area under force extension graph is the work done to stretch the wire. So D is the answer. Number 22, a wire of length L naught is attached at one end to a fixed point. A tensile force is applied to the other end so that the wire extends and has a new length L1. What is the strain of the wire? Still remember, strain is extension divided by original length. Extension is the final length minus original length divided by original length. So you simplify this. Minus L naught over L naught, this is 1. So the answer is A. Number 23, a wire of length L is stretched to determine its limit of proportionality. The graph shows the variation of the extension X or with the force F applied to the wire. The limit of proportionality is shown by point P on the graph. Experiment is repeated with another wire of length 2L but of the same material and same diameter as the first wire. Which point on the graph shows the limit of proportionality for the new wire? I am going to use the Young modulus because Young modulus of both wires will be the same because they are of the same material. Young modulus is stress over strain. Stress is force over area divided by strain extension over original length. I'm going to put L as original length. So my Young modulus will be Fx over AL. Now, FL, it's not Fx, sorry, FL not, FL. So it is FL over AX. So F over X, I want you to see this. This is a gradient of the graph. Right. Now, the gradient of the graph represents the spring constant. Okay. Now, I would say that area is the same. So Young modulus will be the same. This is the first equation. Second equation, use the same wire, but L increases AX. Second equation. So the first equation is equal to the second equation. FL over AX is equal to F2L over AX. So I want you to see this, right? The L increases. Everything else will be constant. F is constant. Um, and the length, okay, length increases. A is constant because the diameter is constant. I would say that is length is directly proportional to extension. Longer the length of the wire, you can extend the wire even more. Right, so the length increases. I don't have to divide actually. Okay, I don't want to. I don't have to show these two equations. I will say that this is the second situation right here. So only look at this. When the extension is when the length is increased, extension of the wire will be increased as well because right, you have more length, you can stretch even more. So when the extension is increases, so what will happen? F over X, extension is increases, the spring constant would be decreased. So the graph would be lower, right, with the higher extension. Graph would be lower with the higher extension, longer extension. Okay, so we will see less steepness to the graph, less steepness, but it has to start with it seems like D is the best answer because, right, you compare A and D, spring constant of A is higher as compared to D. Why? Because A is of steeper, right? Not A is P, right? So D, longer extension. Look at x-axis. So D is the answer. Now, number 24, the graph shows the variation with distance along the wave of the displacement of water particles at a particular instant in a time for a transverse water wave. PQR shows the positions of the three water particles in the wave. Which particle has the greatest speed at the instant shown? Greatest speed, look at the graph. This is a displacement time graph. Okay, not time, sorry. This is a distance, displacement against distance. Distance is for you to find the wavelength, right? If you want to find the greatest speed, you just draw a gradient. So P, 0 speed, Q, okay, and compared to R is steeper as compared to Q. So I would choose R has the greatest speed. That is how you see. Now, number 25, which phenomenon is only associated with transverse wave? Polarization. Because polarization is used to cut down the path of the waves. Transverse wave can travel in many directions because the angle, right? The direction of vibration is vertical, okay? Perpendicular to the direction of travel of the wave. Right, the difference between transverse wave and longitudinal wave is polarization. Longitudinal wave cannot be polarized. 26. A wave is displayed on an oscilloscope. The oscilloscope setting are time-based, equals to 300 microsecond per division, Y gain 40 microvolt per division. What is the frequency of the wave? Frequency of the wave is related to its period. Frequency is 1 over period. Just remember that. Frequency is 1 over period. So my real challenge now is to find the period. So period, I am just going to focus on time-based. Period, I am going to start from maybe, okay, this is the equilibrium position. Equilibrium position is the position, horizontal line, which splits the wave into equal heights. So it is about 3.25, somewhere there. So I am going to start from this point here, maybe. Okay, start from this point. And then I am going to choose, okay, the best answer right here. One complete oscillation. And then, okay, I show you with different colors. Okay, this is a second. Okay, it seems like they ended at, okay, equal position right here. So I am going to count this. 1, okay, 2, 3, 4, 5, 6. It is about 6 and 7. Right, 7 division, because I add with this one, so I am going to say I have 2 period. 2 period is equal to 7 division times my time base, which is 300 micro 10 to the power negative 6 divided by, okay, division. Division and division, you can just cancel. 2 period is equal to 2100 microsecond. Period is equal to 1050 microsecond. So my frequency is 1 over 1050 times 10 to the power negative 6. My frequency is 952 hertz. So I round it off to 950 hertz. Question number 27. An electromagnetic wave traveling in free space is not visible to human eye. What is the possible wavelength of the wave? So if you want to find, okay, just simplify this first. Kilo is 10 to the power of 3. So this is 4.5. 10 to the power negative 10 plus 10 to the power plus 10 to the power of 3. That gives you 10 to the power of negative 7 meter. Right, so this is 6.2 times 10 to the power negative 7 meter. This is 5.4 times 10 to the power, cm is 10 to the power, c is 10 to the power negative 2. This is 10 to the power of negative 8 meter. And then this is 4.2 times 10 milli is 10 to the power negative 3, 10 to the power of negative 7 meter. The shorter the wavelength, the higher the frequency. So the one that is not possible is C, 10 to the power negative 8. Now, number 28. Electromagnetic waves of equal wavelengths are emitted from two sources, X and Y. The waves are emitted from X and Y with a phase difference of 180 degrees. A detector moves along a path that is parallel to the line XY and detects a pattern of intensity maxima and minima. The diagram shows the arrangement of the sources and the path of the detector. And intensity maximum is detected at point Z because they have different opposite phase difference of 180 degrees. They are out of phase, right? Length XZ is 70 cm and length XY is 110 cm. What is the possible wavelength of the wave? So I find the path difference first. Okay, can I do it here? I find the path difference of the two wave. Path difference of the two wave, which is X is equal to n plus 1 over 2 lambda. Why? Because they are out of phase of each other. Right. And then I find the path difference. Path difference, okay, is equal to YZ minus XZ. YZ is 110, XZ is 70. So you just take 110 minus 70 and you get 40 cm. Now I need to try, okay, to use all the choices one by one to check for the correct answer. I am going to start with A first. Path difference, okay, 40 cm. Okay, let's say n is equal to 0. X is equal to n plus 1 over 2 lambda. I choose this lambda. So let's say n is equal to 0. X 40 cm is equal to, no, I want to find the n. I want to find the n because I have, n is a number. So n can only take whole number, but not decimal points. So n plus 1 over 2. A, the lambda of A is 10 cm. I'll try with 10 cm. So I have 40 is equal to 10n plus 1 over 2 times 10, you get 5. 10n is equal to 35. N is equal to 3.5. So this is not the whole number. A cannot be the answer. What about B then? Okay, we try with B. X is equal to n plus 1 over 2 lambda. X is 40. N plus 1 over 2. B The lambda is 16, so I put 16. So 40 is equal to 16n plus 1 over 2 times 16, that's 8. N is equal to 40 minus 8 divided by 16, and you get 2. Wow, is this a whole number? Seems to be correct. But just going to prove C and D are wrong. X is equal to, for C, X is equal to n plus 1 over 2 lambda. X is 40. N plus 1 over 2. What is the lambda of C? This is 20. So you just put in 20. Okay, 20. So 40 is equal to 20. N plus 10. N is equal to 40 minus 10 divided by 20. And N is equal to 1.5. Seems to not be possible right here. And what about the last one? D. Let's look at D. D, X is equal to N plus 1 over 2 lambda. X is 40. N plus 1 over 2. What is the lambda of D? It is given as 40, so you just replace with 40. 40 is equal to 40n plus 20. N is equal to 40 minus 20 divided by 40, and I end up getting 0.5. This is not possible, so the only whole number that I got was B. So B is the answer. Number 29, two waves of the same type overlap. When does the principle of superposition apply? It is always, as long as the two waves overlap at the same time. So superposition will always occur. Number 30, a ripple tank contains water at a constant depth. Water wave of constant frequency travels toward a gap in a barrier placed in a ripple tank. The gap is made smaller. So, which diagram represents the wave before and after the barrier? So, if you want, this is called diffraction, spreading of a wave when passing through a gap. When the gap is smaller, more spreading will occur. So, the best answer is D, circular wave. Number 31. Light of a single frequency from two coherent sources interferes to produce a pattern of bright and dark fringes on a screen, which change result in a larger fringe separation. I write down the equation of the interference. Lambda is equal to AX over D. A is the slit separations. X is the fringes separation. D is the distance from the double slit to the screen. Lambda is just a wavelength. Now I want a larger fringe separation. I want larger X. I make X as the subject, lambda D over A. Now, if you want a larger X, lambda must be made larger, or distance from the screen between the screen and the slit must be larger, or you just decrease the double slits separation. A, increasing the distance between the source and the screen. Right, it seems to be correct to me. B, increasing the distance between two sources. This is A, you have to decrease it, so this is wrong. C, increasing the frequency of the light. If you increase the frequency of the light, you are decreasing the wavelength, so this is also wrong. D, intensity, increasing the intensity of the light. What is the problem? Increasing the brightness of the light would not increase in the larger, okay? Would not increase the fringe separation. That is why A is the answer. Number 32. The current I in a metallic conductor of cross-sectional area A is given by I is equal to A and VE, where E is the elementary charge and V is the mean drift velocity of the conduction electrons. What is represented by the letter N? N is the number of charge density. It is number per volume. So the answer is C. Number 33, which cannot be the charge on a charge carriers. The one that cannot be the charge of the charge carrier is, right, the one that cannot be divided by elementary charge. You try to divide, okay, ignore the negative sign. You try to divide this. 4.8 times 10 to the power negative 19. Try to divide with 3.2. Here, I end up getting 3, negative 3, don't worry. So here, 3.2 times 10 to the power negative 19 divided by 1.6 is not 3.2. Elementary of charge is 1.6. 1.6 times 10 to the power negative 19, and I end up getting 2. This is correct too. Ignore the negative sign because we are not giving the answer. We are just doing the calculation to see which is not the answer. Negative 19, I got the 1.5. And D, 3.2 divided by 1.6 times 10 to the power negative 19, I get 2. So the one that is not possible is the one with the decimal points. So C is not possible. Right, the charge on a charge carrier must be able, is the multiple of the elementary of charge. So the charge must be able to be divided by the elementary of charge and not giving any decimal points. Number 34. A steel wire with a length of 2.2 meter is connected to a battery as shown. The reading on the voltmeter is 1.5 volt and the reading on ammeter is 4.9 ampere. The resistivity of the steel is 6.9 times 10 to the power negative 7 ohm meter. What is the diameter of the steel wire? So you know resistance is equal to resistivity times length of the wire divided by cross-sectional area. But cross-sectional area is equal to pi d square over 4. You just replace it with that. Pi d square over 4. I seems to not having the value of the resistance. So I'm going to use the Ohm's law. V is equal to IR to find the value of resistance first. 1.5 divided by 4.9 and I got 0.306 ohm as the value of my resistance, and I'm going to continue right here. 0.306 is equal to resistivity 6.9 times 10 to the power negative 7. Length of the wire is 2.2 pi d square over 4. So cross multiply here, I got 0.306 times pi over 4. I got 0.24 d square. 6.9 times 10 to the power negative 7 times 2.2. I got 1.518 times 10 to the power negative 6. So d is equal to square root of 1.518 times 10 to the power negative 6 divided by 0.24. Diameter is equal to 2.51 times 10 to the power negative 3 meter. D is the answer. Number 35, two resistors of resistance R and two resistors of resistance 3R are connected to a cell of EMF 8 volt as shown. The cell has negligible internal resistance. What is the reading on voltmeter? You know the function of the voltmeter is used to measure the potential difference between the 2 points. I will put this as potential difference point A, and this is potential, not potential difference, potential at point A and potential at point B. And I am going to use my potential divider concept. So you remember potential divider? V output over V input is equal to R output over R input. So I'm going to solve it one by one. I'm going to use this circuit first to find my potential at point A, VA. So, okay, I'm going to do it here. VA over the total V, which is 8, is equal to R output, okay, which is here, yeah, this is I call this as VA. R output is equal to 3R over the total R, 3 plus R, this is 4R. So VA, R and R just cancel. 8 times 3, just cancel off. 8 times 3 divided by 4. So VA is equal to 6 volt. 6, okay, 6 volt right here. 6 volt, and this is my VB right here, VB. So VB over 8 is equal to R over 4R. VB, R and R just cancel. 8 divided by 4, you get 2 volt. 2 volt. So the potential reading on the voltmeter is VA minus VB. So it is 6 volt minus 2 volt, which is given as 4 volt. C is the answer. Number 36, a battery has an EMF E and the internal resistance R. The battery delivers a current I to a variable resistor and the PD across its terminals is a V. The variable resistor is adjusted so that the I increases. Why does the V decrease? So this is related to internal resistance. EMF is equal to V across the variable resistor plus potential difference across the internal resistance. Since the I increases, could you see that? The whole thing here, the V potential difference across the internal resistance will increase. And the value of EMF is constant. So that is why the potential difference across the variable resistor must be decreasing. So I would say A, EMF is decreases. No, EMF must be constant. It is the same battery. B, the internal resistance of the R increases. No, since it is the same battery, so it has the same internal resistance. PD across the internal resistance increases. Yes. So the resistance of the variable resistor increases. No. C is the answer. Number 37, an electrical device of the fixed resistance 20 ohm is connected in series with a variable resistor and a battery of EMF 16 volt and negligible internal resistance. The power dissipated in the electrical device is 4 watt. Okay, what is the resistance of the variable resistor? So the power dissipated is 4 watts. So I am going to find the PD across the electrical device. PD across electrical device. I'm going to use P is equal to V square over R. So power is 4, PD is V square, R is 20, V is equal to square root 4 times 20. And I got 8.9 volt. So this is 8.9 volt. And then the PD across the variable resistor is 16 minus 8.9, which is equal to 7.1 volt. And I need to find the potential difference across the resistance of the variable resistor. Since I do not have the value of the current and this variable resistor and the electrical device are being connected in series, I want to use my potential divider. So I put PD across the variable resistor 7.1 divided by the total PD, which is 16, and then R across the variable resistor, which is R over R plus 20. Cross multiply 7.1 R plus 20 is equal to 16R. 7.1 R plus 142 is equal to 16R. And then I take 16R minus 7.1. I got 8.9R is equal to 142. R is equal to 142 divided by 8.9. And I got 15.956 ohm. I round it off to 16 ohm. So A is the answer. Number 38, a nucleus decays by emitting a beta plus particle. Which particle must also be emitted from the nucleus? If you see beta plus, it is together with a neutrino. So neutrino is the answer. Number 39, what are the charges on an anti-down quark and anti-strange quark? First of all, you need to understand that down quark is negative 1 over 3e. Anti-down will take positive 1 over 3e. Strange is also negative 1 over 3e. Anti-strange is positive 1 over 3e. So A is the answer. And number 40, the nucleus of a radioactive isotope of an element emits an alpha particle. The daughter nucleus, okay, I'm going to do it first. A, Z, I put A, emits alpha particle. So you get A minus 4, Z minus 2. I put this as B. This is called daughter nucleus. So the daughter nucleus, after that, Z minus 2, emits beta negative. So I get A minus 4, Z minus 2 plus 1, minus 1, C. And then this daughter again, A minus 4, Z minus 1, C emits, okay, of that reaction, emits another beta negative. So I get A minus 4, Z minus 1 plus 1, you get C. This is nucleus D. Right, so which statement describes the final nuclide that is formed? This is a final nuclide. I would say that, okay, let us look at A. It is a different isotope of the original element. Seems to be true. D is isotope of A because they have the same proton number. B, it is a nuclide of a different element of higher proton number. No, same proton number. C, it is a nuclide of the same element but with different proton number, same proton number. D is identical to original nuclide. No, the nucleon number is different. So, and that's it for AS Physics Major 2025. Paper 1 Variant 3 discussion. If this video helped you clear up tricky MCQ questions, right, or boosted your confidence, don't forget to like, subscribe, and hit the bell. See you in my next one. Bye.